Here we have a statistics question, and when you try to solve a statistics question, you need to know what type of question it is. And if you read this, you see that it's asking to estimate the mean of the entire population from the sample. So the most important word here is it wants to estimate the mean of the population, okay? And once you know that's what you're doing, then you should be aware that the purpose of this question is to come up with this sample's mean and use that. So the sample mean value x bar would be an approximation of the mean value of the entire population, right? And you could also expect that the bigger your data set is, the sample mean will get closer and closer to the entire population's mean, and that's called the central limit theorem. But because we only have like 12 physicians, 12 data sets here, it's going to have some errors. So the concept is to think about this margin of error, and the formula for margin of error is given as the critical value times the standard deviation of the entire population divided by square root of n. Now, we can use this formula only because the entire population is normally distributed and we know its standard deviation. The standard deviation is 8. In most cases, unless your sample size is bigger than 30, you don't have any justification to be using this one. You have to use something called a student's t-distribution. But for us, we don't have to worry about this one because right now it's normally distributed and the standard deviation of the population is given to us. So that's what we're going to use. Okay, so because I need to calculate this, we need to calculate the critical value z alpha over 2, which is calculated by inverse norm of 1 minus alpha over 2. And the alpha is defined by this formula. And let's see what alpha is. Confidence level is 95%, 0.95. That has to equal to 1 minus alpha. So alpha must be 1 minus 0.95, which is 0.05. And then from there, you need to calculate inverse norm of 1 minus 0.05 over 2. And that's inverse norm of 0.975. Okay, we'll need to use the calculator to find this value. So turn it on, and then you have to do second vars, and then you want to go to inverse norm. Area will be 0.975, then enter. And that value is 1.9599, and if you round it from somewhere here, it's still 1.96. So 1.96 is a pretty good approximation. So let's write that down. That's 1.96. Therefore, our margin of error would be 1.96 times 8 over square root of n is the sample size, and because our sample is size is 12, we calculate that. So let's see, we can do 1.96 times 8 divided by the square root of 12, and then enter. I get 4.526. Okay, 4.526. Now what remains is we need to calculate the average of our data, and there are two ways. One is to just add everything and then divide by 12. That will be one way to do it. But I also want to show you how to use the TI calculator to input the table. So you can go Stat and click Edit, and you can edit in the input lists here. So let's put those numbers in here. So those are 6, 44, 17, 2, 34, 40, 18, 14, 19, 28, 11, and 51. Okay, so once you have that, then you can second quit. Now you can go to Stat again and go to Calc and click the one variable stats on the first list, L1. So you calculate, and it gives you the X bar. This is the average of the sample, which is 23.666 or 667. Okay. It also gives you other values like the sample mean, and if this was a sample, and then you want the population's mean from the sample, it would be slightly bigger. It would be 15.6, and so on and so on. Okay. All right. So we have the number we want, 23.666. So let's write that down as well. We have X bar 23.667, and therefore the confidence interval is X bar minus the margin of error until the X bar plus E. So the mean value of the population should be, with 95 confidence, we know that it should fit in here to there. And that's a powerful way to see how close this sample mean is to the actual mean. Okay. All right. So let's try to compute this. 23.667 minus 4.526. So calculate that. Second quit. 23.667 minus 4.526 gives you 19.141, and then again 23.667 plus 4.526 gives you 28.193. Okay, so 19.141 comma 28.193. Okay, so that will be the interval where we know that the sample mean resides with 95% confidence level. And of course, the more samples you have, this value will become smaller and smaller, and the sample mean that you get will give you a smaller window for mu, and that will give you a better idea of what the population mean would be. Okay, so that's why you would want larger data size.